When you're asked to evaluate an inverse trig function, that means you're trying to find the angle at which that particular trig value happens. So if I'm doing something like this problem, sine inverse of negative rad 3 over 2, the first thing I want to do is go to my reference angle chart and find out where is sine equal to rad 3 over 2. And I've circled 60, so that is my reference angle. However, this particular value is negative, which means I need to go to my other chart where I'm told where each function is positive and find out where is sine going to be negative. That's going to happen in quadrants 3 and 4 because that is where tangent and cosine only are positive. So to find an angle in quadrant 3 with a reference angle of 60, I'm going to do 180 plus 60, and that's going to give me 240, so that's one of my answers. Then for quadrant 4, I'm going to do 360 minus 60, which gives me 300. So those are the two values of theta that would satisfy this equation. Another way that an inverse function can be represented is this word arc in front of the function. So this is just another way of saying find inverse tan of rad 3 over 3. So find the angles where tangent is equal to rad 3 over 3. So I'm going to go back to my chart with the reference angles, and I can see that tangent at 30 degrees is rad 3 over 3. So that gives me my reference angle. So now, because my value is positive this time, I'm looking for the two quadrants where tangent is positive. And that would happen in quadrant 3, where the t is, and also quadrant 1. So that means I need an angle in quadrant 1 and 3 with a reference angle of 30. So in quadrant 1, that is just going to be whatever my reference angle is, because that is how far away from the x-axis I am. To find the angle in quadrant 3, I would do 180 plus 30 to get me 210. So that is the other value of theta that would satisfy this equation.